Example 4. Example 4 is the same as example 3. We're given the same two functions, f of x equal to x over x plus 3 and g of x equal to 2 over x. But in this example 4, we're first asked to find the composite function and then state the domain. Just notice the difference. From in example 3, we were never asked to find the composite, we were just directly asked for the domain. So we obviously want to come up with the same answer, but we're going to do it in a slightly different way because we're first going to find our composite function. So we know that f composed with g means f of g of x. So I'm going to plug in, I'm going to work inside out, and I'm going to plug the function g of x into the outer function f of x. So g of x is equal to 2 over x. So I'm going to replace g of x with 2 over x. So I want to find f of 2 over x. So I want to substitute now a 2 over x into the function f. So wherever I see an x in the function f, I'm going to replace it with 2 over x. So this will give us 2 over x over 2 over x plus 3. So now we have a complex fraction here. We've got fractions within a big fraction, little fractions in a big fraction. So remember, a convenient way to clear out those little fractions is to multiply by the least common denominator. So the least common denominator of all three of these, the 2 over x, the 2 over x, and the 3, we look at that as 3 over 1. So we can see our least common denominator here is going to be x. So if we multiply the numerator and denominator of the large fraction by x, that's going to clear out those fractions. So 2 over x times x just gives us 2. And then here again, 2 over x times x gives us 2, plus 3 times x, which is 3x. So our composite function is 2 over 2 plus 3x. So now that we know the composite function, it makes it a little easier to find the domain of the composite function. So this would be case 2 from our steps. So actually, if you want to label that, this example 4, this would be case 2 from the steps on the previous page. Example 3 was case 1. Okay, so let's proceed here and find the domain of this composite function. So our first step is the same in either case. We want to look at the inner function, in this case g, and find any values to exclude from the domain of g. So g, again, it's a rational function, so we know the denominator can't be 0. So if we had a 0 in for x, that would make the denominator 0. So our excluded value of g will be x is equal to 0. Okay, now we want to look for excluded values of the composite. So here's our new composite function. This is also a rational function. So we want to find the zeros of the denominator. So if I set the denominator to 0, so we're looking for excluded values or value of f composed with g. So I'm going to set 2 plus 3x equal to 0, isolate the x, and we're going to get a negative 2/3. So then finally, step 3, our domain of our composite, we will just have to exclude anything from step 1 and step 2. So our domain will be the set of x's such that x does not equal negative 2/3 or 0, which is exactly what we got up in example 3 using just a slightly different method. So I'd like you guys to now try part B here, g composed with f, on your own.